Hello, so let's go ahead and be looking at part D, okay? So we finished part C, we're going ahead to part D. So it says in a second experiment, the bullet is fired with the same velocity and the block is placed at a distance L from the end of the right end of the table. Friction is present in this trial. Find the minimum coefficient of friction so that the block doesn't leave the table, okay? So here, what we're really asking is we already have this bullet embedded. We know the initial velocity of the bullet block system because we already found that, right? We know that the initial velocity is this part right here. We actually know that this right here is the whole kinetic energy I have at the beginning, okay? But here, we want to know, I know the distance here is L, right? I want to know what mu do I need in order that with initial velocity it slows down and stops, okay? And so there's a couple different ways to find this, but I think that the easiest is with energy, okay? I know that the velocity at the end is going to equal 0, okay? And the velocity at the beginning is equal to my x root g over 2h, okay? And so if I think about this as a work equals the change in kinetic energy, right? Then all I need to do is do F times D equals KEF minus KEI, okay? And you'll notice that the KEF is actually just 0 because I need to end at the bottom, right? Now my force is also negative, so because I have a negative and a negative here, I can actually just cancel that out. So the formula for my force is mu Fn, and then D is actually going to be L. And then I have 1/2, and I'm going to go ahead and plug in this m plus m x root g over 2h squared, okay? And so we need to figure out what my Fn is. Well, I'm going to go back to this. I know Fn is equal to mg, right, in my case here, because I don't have any other forces in the y direction. And my m here is really equal to capital M plus m, okay? And so I'll have mu, that was pretty ugly mu, capital M plus lowercase m times L equals 1/2 m plus m, and then x g over 2h squared, okay? Let me make sure I square root that. So you'll notice that these cancel, okay? I'm solving for mu, okay? So I'll have mu equals 1 over 2L times x squared times g over 2h, okay? And so that would just equal x squared. Sorry, I made a mistake. Did you catch the mistake that I made? When I plugged in for Fn, I dropped something, right? I forgot this g, okay? So I have a g here when I divide by, or I will also divide by a g here, right? So divide by g and L, and so these g's will cancel, and so then I will be left with just 4LH, okay? And so my final answer for D would be x squared 4LH, okay? Remember, if you have any questions or confused about something, feel free to send me an email so I can give you a better answer to a particular question, okay? But that concludes this video.